right. Hello, everybody, and welcome to this session's our bootcamp class. I am Evelyn Pinky Stratmoen, and over here in the corner is my colleague, Angela the Brain Rose. I don't know why she's covering her face. Not like we're recording via video. Today we're going to go through some R coding when it comes to general linear modeling. We're going to specifically more focus on ANOVAs and regression techniques. So I'm going to focus on the ANOVA. I'm going to do a one-way ANOVA and a two-way ANOVA. Do some like multiple comparisons, and I have some coding for some basic graphs that you can look at. It's not ggplot 2, so because that's not my forte. That is not something I feel comfortable doing a bootcamp session about. But if you're interested in looking at your data and kind of getting a look at the means. Has everyone gotten or downloaded the PDF file that's on the website? The website I have up here, so if you need to see what the web address is, you should be able to upload or like download the markdown file so that you can just copy and paste the code as you need to and go from there. Okay. Also, if I need to stop or slow down or something to let you guys catch up, please raise your hand and let me know. Because, all right. Fast. All right. So whenever Angela and I discussed what kind of data sets we wanted to use for this specific one, we decided that we wanted to showcase some of the data sets that the R software package or packages comes with. They come with a wide variety that I know some of you guys in Mike's class have used before. But in terms of having like an R markdown file or having it known to the public, or if you guys want to share this markdown file with like undergrads, that sort of thing. I know myself when I started working with R, it was very intimidating, and I got nervous about wanting to play around with my own data set as if I would break my data, which sounds stupid, but that's the way I felt. But I think knowing that R has data sets, so you can't break those data sets, right? You can only play around with them, I think is super helpful. Now, when it comes to the ANOVAs that we're going to do, they're between subjects, but the data sets that I've chosen, the chick weights and the warp breaks, they're actually repeated measures data. So this isn't the proper way that you would want to conduct analyses, because you would need to account for like specific participant time points or whatever.
Is R capable with repeated measures?
Yeah. I think you guys want to do that with generalized linear modeling techniques. Yeah. But I wanted to use these because one, you might have seen these, at least with chick weights in Mike's class, so that'd be a little familiar. And these are nice, easy data sets to understand what the variables are. Just know that this is not the appropriate analysis you would want to do with these specific data sets. So when it comes to uploading a data set that's already in R, you would just have to go into R and then you would type in data and then put in the parentheses and then start typing in whatever data set name. So whenever I'm using RStudio, for those of you at home, and types in and it automatically pops in, like populates some names. So there's chick weight. So click on that and run, and then you should see down here in the console that there's no errors. And so that tells me, yay, Evelyn didn't mess up. Anyway, that's because you have no idea. The errors really freak me out. So after that, I was also wanting to show the wide variety of different ways that you can view your data set. I know Kelsey had described those also in the introduction. I'm not going to go through all of these because right here's the coding, but if you wanted to look at the first few rows, however many rows you wanted to do, like 10 or 6, you would just put in head and then the name of the data set and however many first rows you wanted to look at your data set. So my example in the markdown file, I put in first 6 rows. If you want to actually bring up your data set into a separate window, like I'm going to do here, you would use the view command. So I'm going to put capital V, found that out last time because I kept using lowercase v and didn't understand why it wasn't working. Anyway, view chick weight, and then you should see that the data set populates up into the window. Okay. So in this basic data set, we have the variables of weight, and we have various time points, different chick
chicks being baby chickens, not chicks as in a sexist word we call women, and different diets that they were assigned to. So in this specific data set, baby chickens were assigned to one of 4 different diets, and then they were weighed throughout different time points as to how much they weighed. So for this one-way ANOVA that I'm going to show you guys, we're just going to focus on the mean differences of weight versus like the 4 different types of diets. Oh, also, I forgot to mention, there's a package called Psych for anybody who's interested in a wide variety of other different types of descriptives that we sometimes use in our field. You just have to actually load, like install and load the library Psych, and then you can look at it like all the different types of, actually, do we have time to do that? We probably don't have time to do that. But especially when it comes to ANOVAs, not only do you want to know the means, the standard deviations, and report those for like your overarching sample, but it's also important to show the means and standard deviations per category, or in this case, per diet. So here in the markdown file, the only difference in the, you would have to do describe by is the command, and then you put in what the variable is that you want to do, and then it goes by each individual group in that variable. So they have group 1, 2, 3, and 4. All right. So the one-way ANOVA, we have to load in the library MVN. So if you have not installed that, I always like to go into the packages part right here for myself and click on install and find it. This is the way I do it. And I click install. I know there's a way you can type in coding. What? Do I have to restart? I don't think I have to I don't think I have to install. I hope not. I don't want to restart R. No, I don't. But if you need to install, they might have to restart R, which that's up right now since I'm going to move on. Sorry. But you want to load in the library MVN. That's going to allow us to use the ANOVA function. And then, yeah, go ahead.
Is MVN only for team group one-way ANOVAs, or does it give you a variety?
You know, I don't know the answer to that question. I'm not super smart when it comes to R. I just know that's the library I need to use in order to use ANOVA. But that's a good one to like look up and determine if that's one I would have to do for between group. I mean, for other groups. The basic formula I put right here in terms of how to type it in, because sometimes it's nice to have a basic formula, is you want to name your model, and then the function name is AOV for ANOVA. And then you have Y, your criterion is predicted by X, and then your data set. So here I called it residuals ANOVA because I'm trying to be like Mike. So I'm copying it over here. So we have the name of the title of the model, and then AOV is the function. And then if you want to see the actual results, because if you notice down here in the console, I didn't get an error message. So old Evelyn's like, yay, I didn't fuck up. Anyway, but Evelyn's like, but where's it at? You have to hit summary. So you have to click on summary, and then you have to type in the name of your model. And then it pulls it up here. So let me pull it up real quick for you. And there's our ANOVA. Bam. Look at that p-value, crazy. But that's because we have lots of data points for one chick. So we're not interpreting stuff, we're just showing you how to use stuff, okay. But let's say that this was a legit data set that we would want to do a one-way subjects with, and that's significant, so I would need to do multiple comparisons. So in this case, I could use 2Ps. So 2P HSD, and then you put in the name of your ANOVA right there, since it's just a one-way ANOVA, it's just one subject. Everything okay, Kelsey?
Yeah, I'm just, it's just very fuzzy.
Is it fuzzy? Yeah, I'm sorry. Which one? Right here?
plus. I think it'll make that tax bigger.
Oh. Control plus.
It's command plus on the Mac.
Oh.
I'm sorry.
No, you're fine, you're good. It's the same information as what's in the PDF file.
It's control plus. If you go to view, you don't have to, I'm okay. I just was trying to.
Oh, zoom in. Ah, so, okay. Yeah, no problem. Is that better?
Yeah.
Okay, excellent, all right. All right, and so then with the output, that output automatically comes up, and then it does the differences between each individual level, like group 2 versus minus group 1, et cetera, right there. All right. Also, when it comes to ANOVAs, we usually like to have some kind of an effect size, want to report effect size. The first one we usually think about is Cohen's d. I spent quite a bit of time trying to find how to do Cohen's d in R, and you can, but they only, unless you guys find something that like I didn't find, the only code I could find is if you have a 2 level only. It only compares group 1 to group 2. Since we have 4 levels, I found coding that allows us to find eta squared. So we have to load in a new library in order to use the eta squared function. So if you haven't installed it, you would have to install LSR. And since I already have it, I think, yep. Once you've installed it and load it, then you can just, it's eta squared, the S is capitalized. And then it's the name of, I think it's the name of your ANOVA, isn't it? Yeah, it's the name of your model. And then it pulls it out right there at the bottom. And then when it comes to visualizing variety of things with your ANOVA, you can, in terms of visualizing normality of your DV, I think Angela's going to talk more about that. Is that right? Okay, so I'm not going to go into too much detail since I don't want to take up all of her time. I could if I wanted, but I don't want to. I'm not that kind of colleague. You can visualize the normality of like any kind of continuous variable, but in this case, our DV, by using the histogram function. And you just have to make sure to use your $ whenever it comes to naming the data set, $, and then the name of the variable. So in this case, if I wanted to visualize the normality of my DV, I would do chick weight, $ weight, since that's the name of my DV. But once again, because this data set's a little off because of all the repeated measures, you can't trust necessarily the normality of this DV. But this is just an example of what it would look like whenever you populate it up. Right, yeah. So like, because it's data set name first, $, and then variable name. That's going to be pretty standard practice with like majority of R stuff. You can also plot residuals. So I found one, we put the word plot and then the name of your ANOVA model. So in this case, mine was RSAOV. I don't know why the number 2. Sorry, maybe it's because it's, I don't know. But anyway, this is a QQ plot. And crazy residuals, not very normal, but once again, it could be because of the structure of the data set. This is not an appropriate analysis to do anyway. You know why it's a 2? Why is that?
Because if you just run the command with plot, it will actually take you through a series of 4 different ways of viewing your residuals.
Oh.
And the second of those plots is that QQ plot.
Oh, okay. Oh, I gotcha. So like this one is just the second, it's just the second one.
I think so.
Oh, okay. All right. Well, sounds great.
Sometimes you just want one though, and that's
No. And
I didn't know.
Well, I like QQ plots. I don't like making them in terms of hand by hand, but like you can visualize and see like this is not normal data. Right, it does. Then you can look at for like, for ANOVA, we also have the assumption of homogeneity of variance, right? That the variance between groups is the same. So you can use, well, that must be why that's a 1 then, because that must be the first plot. Oh, Oh, Lisa, smart. So this would be a way to plot the variance to determine if the variance is the same between groups, or if you want to run the Levene's homogeneity of variance test. That's in the CAR library, C-A-R, which is a pretty common library to use with a lot of other different types of analyses in R. And then you would just type in Levene test, and then type in weight by diet. And then this gives you the analysis. And I didn't know if anybody would know how to interpret this, so that's why I put technically by these results. This is very, very not homogeneous. Our variance is off. But you could tell that based on the other plots. All right. And then basic plot of our data. If we use G-plots, not ggplot2, but G-plots, you want to plug that in, and then you can just copy and paste the plot means right here. This is plotting the group means using the 95% confidence interval. But I need to load in which one. Just G-plot, right? Yep, G-plots. There we go. So again, this, I don't know if this would be a plot you'd want to use in a publication. ggplot2 is a much nicer, makes very, very pretty graphs. But if you like looking at the structure of the data and where those differences might lie, that sort of thing. Like we can see diet 3 and 4, chicks grew heavy. Anyway, okay. All right, so when it comes to the two-way ANOVA, we can visualize the data the same way. We're going to use the data set warp breaks. So if you want to load in warp breaks, this is a data set that looks at I'm going to put view warp breaks. Oops. I'm not used to an intern not running stuff in RStudio. All right. This here gives us a data set of where we have a number of breaks within yarn. And it was by whether it's the type of wool and the type of tension. It's low tension, medium tension, high tension. And then they had two different types of wool, type A, type B. So we're going to do a two-way ANOVA using these two categorical variables and looking at differences in breaks, group differences. So the basic setup in terms of how to type it up is your name of your model. Again, it's an AOV, but it looks like the majority of us have taken Mike's class and Jen's class before. Is that right? Is Cassie's the only one? Okay, all right. So when it comes to like for the first ANOVA, we just had our Y variable is predicts with a little tilde, is predicted by our X variable predictor. But when it comes to R, the general linear model, we can add in however many main effects we want. So this first one that I created here in the R markdown file is just testing the two main effects. It doesn't test interactions. You can build your model any way that you want. It's a pretty nice feature. So here, if you only want to test the main effects, let's say you were not interested in the interaction between wool and tension on number of breaks, then that would be how you would want to write it here. Number of breaks is predicted by wool plus tension, and you want to state what your data set is. And then it gives you all the ANOVA output that you would need. But we are interested in the interaction. So in R, when it comes to building that model, there's two different ways you can do that. The colon sign in R stands for, well, anyway, I know the colon sign means to multiply. So in order to create an interaction between two variables, you have to multiply the two variables, wool times tension. So that's where that is right here. So you could actually physically type it in as weight number one, which is not that hard considering we only have two variables here. But let's say you had several predictors and you're wanting to run a full factorial ANOVA, like a three-way ANOVA or four-way ANOVA,
And you don't want to type in everything because you don't want to miss the main effect. Or you have to remember all those two-way interactions and three-way interactions you have to include. So the other way you can do it is using the star. The star in R means like a full factorial. So it knows to include all of the main effects and interactions that are possible between your two variables. So depending upon what your needs are and what your research question is, depends upon which method you can use. But whichever way that you do it, you get the same information. Like your results are exact same. All right, so I'm going to put in ANOVA 4. I named these all ANOVAs. Thought those were better names instead of ResANOVA. Sorry, Mike. All right, so ANOVA 4, and I'm using the full factorial star button to run it. And then once again, you have to also click on, you have to type in summary in order to see the actual results of your ANOVA. With any kind of factorial ANOVAs, if you have a significant interaction, you'll have to do simple effects. I did not go into detail here because that requires you to split up your data file by levels of one of your categorical variables and do mini ANOVAs. But I did include I found a website that kind of goes into a little bit more detail for that. Because I need to do simple effects in order to probe the interactions. But we do have a main effect of tension, and tension, it's a little bit different in terms of how you would write it since it is within a factorial ANOVA rather than the first ANOVA that we did. So I went ahead and I wrote, you have to put which variable that you're wanting two keys to be conducted on. Because on the first one, there was only one predictor. So it already knew which predictor it was doing it on. And then it provides that same information for two keys. And then I found a different kind of plot. We can do a neat looking box, a basic box and whisker plot. This would be in a library GG pub R. Oh, I did it again. It's gonna be such a hard habit to break. Huh? Control Enter. Control Enter. All right, and then this right here is the coding that gives you some basic box and whisker plots there. I try to give you some details in the R Markdown file as to what each part is looking at. Plots number of breaks by groups, and then the color is the second group wool. You can switch that if you want by making sure to switch up the names of the tension and the wool here. So if I click on run, I have this beautiful plot right there where wool is the different colors, A and B, and my tension is down here along the x-axis, low, middle, and high. Okay, before I hand it over to Angela, are there any questions? I feel like I went through that pretty fast. Yes.
You stole my question, Angela, gosh.
Well, you know, this kind of awesomeness doesn't happen overnight. You know, you have to work hard at it. No, thank you. But seriously, any questions on that so far? Okay, I haven't played around with simple effects, so if you guys ever do that, I would be learning too at the same time. But okay, all right. Yay, Angela's turn. Thank you.
So I just scroll down in this, right? This is the, okay.
Yeah.
Yay. You don't want this R script, right?
You can delete it.
Delete
Yeah.
it. I'm just gonna do this. Okay. So for the regression, we're gonna play around with some linear regression as well as how to maybe eliminate people that you don't like in your data. So people who didn't pass your attention check. I'm serious. So like bad participants or data that you want to eliminate, and then how to do some transformations of your variables and how to save a new data file, things like that. So first, like Evelyn said earlier, we thought it would be really cool to play around with some of the data sets in R. And the data we're going to be using is called attitude. So we're just going to do view attitude, and it's already in here, so you don't need to load anything in or anything like that. And here we can see our data. So we have the Y variable as rating, which is the overall rating of a department. And then we have complaints, privileges, learning, raises, critical, and advanced. And these are just all, different questions that people answered either positively or negatively about their department. So complaints would be, how well does your department handle complaints? If they gave a positive answer, then it was 51% of people in that department gave a positive answer. So I have no idea where this data set came from, but we're just gonna play with it because why not, right? So if you have another hint in here, a little tip about how to load in your own data set. So I know Kelsey went over how to set your directory and then load data set files that are in there. I usually load my data set in using the read.csv command. I'm not gonna do it since this is Evelyn's computer and I don't have data on here, but you would just do read, you would name your data. So let's just do, Mike calls it MyD like this. And for a long time, I thought it meant Mike Young data, but it just it just means my data. But now I can't use that command because it's not Mike Young data, it's Angela Rose data. But we'll just go with data and then read.csv, file.choose, and you have to make sure to enter this little parenthesis. And then when you run that, it will open like a normal file browser on your computer. So if you don't have your data saved in a certain area, maybe the directory, you can go through and then find it wherever it's saved on your computer if it's in a different folder. This is how I just usually do it because I end up with things like in my downloads or on my flash drive or from my email or whatever. So I'm not going to run that command because our data is actually inside R already. Now, if you wanted to do a quick summary of your data like Evelyn did earlier, you just do summary attitude. You notice it pops up there in RStudio because it's in R already. And you have your typical, like you have your median, mean, first quantile, third quartile, max, min, stuff that you probably don't really use, but the mean is important for later, so we'll keep that. And this is just talking about where we get the data sets. Now, if we're going to run a linear regression, we probably want to figure out which variables we're going to use, right? So out of my own curiosity, I thought complaints, right? If I'm working for someone, I want them to handle my complaints well. So maybe that's pretty important for their department rating. And then I thought raises, because people like to make money when they're working hard, right? Sure, I have no idea if that's true or not, but that's what we're gonna do. So making a model is really easy. So we're just gonna start off by naming our model. I name mine model 1. This is the first model that I'm doing. And here I give you like a generic command that you plug in your own variables. So you can see that it's your model name, and then you're using the lm command, and then your y variable by all of your x variables, whatever you're using, and then your dataset name. So one other tip, I think I get to it a little later, but I'm gonna do it right now because I like to, is attaching your dataset. If you attach your dataset, you don't have to write the data name every time, but every time you would do something else, you either have to reattach a different dataset over that, or you would have to specify the data name so that R knows what you want it to do. So I'm doing attach attitude. So it's all attached there, and this is the default data set that it's going to pull from. So I could write my model like LM parenthesis rating by complaint and plus this is right. Now, if I didn't attach my data set, I would add this comma data equals attitude, right? If I could spell attitude correctly. But I attached my data, so I'm not going to put that, and it's going to work anyway. Ta-da! Now, if I want to do a summary of my model, I just do summary model 1. And this gives me my output. So you have everything that you typically use there. You have your estimate, your standard error, t, p-values. You have the omnibus test, which is hidden way down at the bottom. It's just the f statistic. And that gives you your f value and your p-value for that f. So let's go back over here. Oh, I did talk about the attached data set there. Right. And if you didn't add attach your data set, you just write it right there with the data on it. And there's our summary. Now, if you wanted to compare this to another model and you want to grab your AIC and BIC values, it's actually super easy. So you would just type AIC model 1, the name of your model, whatever you named it, run that. It pushes out your AIC for you. Let's say you want BIC, model 1, pushes out your BIC for you. And you can do this for every other model.
Does it do R squared?
There is an R squared, yep, in
Oh, is it already
the
in
output.
there?
Yep, it's in the output. You have your multiple R squared and your adjusted R squared right above the F statistic there. So if we're looking at the screen, right about here. Now, if you wanted to run another model, so let's say we wanted to look at interactions. So I'm going to name it model 2 because it's just my second model. We're going to do LM by rating by complaints plus raises. So if we're doing longhand, we're doing complaints plus raises plus complaints by raises like this. So what I'm doing here is I'm telling you I want you to look at this variable, and their interaction. But like Evelyn said earlier, I don't have to run that one. I can run, well, actually we will run that one, sorry. And then let's say I want to do shorthand, so I would just do like model 2.5 because he's better. LM rating, so your Y variables by complaints, and then the asterisk raises, and this does, like Evelyn said earlier, all of your main effects and your interaction. Okay, and if we ran that, then we could do a summary of model 2 and a summary of model 2.5, the better model, not really. And you'll see that they are exactly the same. So you can see, if you look at the estimates, standard errors, p-values, then you'll see they're exactly the same because the notation is the same. It's just one is longhand, one is shorthand. Let's see where we are at. Oh, and if you wanted to get AIC values of multiple models, you could do that by just doing like AIC model 1, model 2, model 2.5, and we'll give you all 3 of them at once. So you don't have to do it for each one and then remember it. And this works for BIC as well. If you wanted to check your residuals to see if they were normal, super easy as well. You can just do plot resid, which is residuals, if I can spell, and then type your model name inside the next parentheses set. So then if you run that, you'll get this graph right here of your residuals. You can see 0 is in the middle here, and you can see it's not too bad. You could do this for any one, so you could do plot resid model 2, and then you would get residuals for model 2. Not very different. You could do a histogram of the residuals by using the same hist command that Evelyn showed you earlier, and then just do residual model 1, for example. You'll get a histogram of the residuals of model 1. I believe if you wanted to, sorry, let me think. Yeah, we could do plots of our model as well. So of the outcome of our model, and also the residuals. If you do plot model 1, it gives you those 4 plots. You just have to keep hitting enter to see all of them. Am I going too fast? Are we okay? Yeah. Okay. So you can hit enter and it will show you the next plot. So here's my residuals versus my fitted, my QQ plot, scale, location plot, and I believe a leverage plot. And these are the 4 by default that I think we were getting with just the one number that we were using earlier with the ANOVAs. So if you have any use for those, you can, and you can always get the better plots with the ggplot. It's just more complicated to use. You have to be very specific about what you want. Now, when you make a model, you might want to predict something with your model. So you might want to look at the predicted values. So if you do fitted, I think we'll do a summary first, and I will give you all the fitted values. So if we do summary of fitted model 1, run it. That's not what I wanted. Maybe if I just do fitted model 1. Yeah. So here are all my fitted values for each department. So there are 30 different ones. If I wanted to plot my actual Y data versus my fitted values, I would do plot x equal rating, because these are my actual raw data, and then Y equal fitted model 1, or whatever model you're actually using. So you could use model 2, whichever one you decide on. So whatever model name you want to use, run it, and here's your fitted values by your actual raw data. Okay, so you can see how well it's lining up with your raw data or not. And again, you can get prettier plots in ggplot too. This is just going back to model 2 stuff. Apparently I did that too early. If you wanted to compare models, you can do it pretty quickly. So if you weren't using AIC and BIC, for example, you can actually do an ANOVA to look at the difference between the models. So if you wanted to know if it was actually different or not, you could do ANOVA model 1, comma, model 2, and that will compare the two models. You just run that and you'll get an F-test that tells you whether they are significantly different or not. You can do this on as many models as you want. Just enter your model names in there. Okay, so if you want to do 3, say you wanted to add model 2.5 in there, you could do that. Ooh, let's do transformations. So you're like, hey, my data is not normal and I want to transform any of my variables. Okay. How do we manipulate the data set in R to do that? So what we would do is we create a new variable by using the name of the data set, so attitude. I forgot how to spell attitude today. And use your $sign. And the $sign is just saying, well, you know Rihanna song, bitch better have my money, right? This is how I remember. $sign is just saying, the $sign saying, hey, go here and get that for me. Or I'm giving you this and I want you to go put it there. So like, bitch better have my money because you better go over there and get it, right? So if so let's say I wanted to do a log transformation of rating for whatever reason. This is my data set, I don't know. So we're doing log rating. So I'm naming my new variable log rating. Okay. And I'm going to put equals, and then you need to tell it the mathematical equation you want it to run. So I want it to do a log of rating, right? So I'll do log rating. Okay. And what it will do when I run that command, and again, a lot of these, you might have to specify your data. So if you try and it doesn't work, and you didn't attach your data set, you might have to specify it. So just keep that in mind. I'm doing everything because I've attached my data already, and I don't need to put data equals every single time. Now, if I want to view that, if I click on attitude up here, it's not there yet, because when I said, hey, show me that picture, R showed me the picture from the first time. I have to say, hey, show me the picture again, right? So I've changed it, I want to see it again. So I need to use view attitude again to be able to see the change. And now you can see that it's been updated and there's another log rating column here. Okay. Now, if I wanted to, let's see what I have next on here. Yeah, so if you wanted to center your variables, for example, you would just do something very similar where you create a new data column. So you do attitude, $sign, because bitch better go get it, and center whichever one you want to center. So if I want to center complaints, I usually do C dot whatever it is, so I remember it's the center version. So I do C dot complaints because that's what I want to name it, equals, you have to get your means back again. So if we go up real quick and we do summary of our data set, so attitude, look at it again because I don't want to scroll up. So here's complaints. It looks like my mean is 66.6. So what I would do is type complaint minus 66.6. This is how you center. Oh no, it's complaints with an S. See, errors are fun. Now again, if I go over here to attitude, it's not there. I need to say, hey, show it to me again. So I do view attitude. Ta-da! It's there now. So I have my centered variable. Now, because I attached attitude before I change this, if I want to use these variables, I need to attach attitude again, right? So if I do attach attitude down here, run it, and then you get all this red text, but that's fine because all it's telling you is that it's taking these variables you wanted it to attach just now and masking the old variables. So it's overwriting the old variables. So in this case, they're the same, so I don't care. But it is a lot of red text, just don't panic, it's okay. It's what we meant to do, right? Now, is everyone still okay? Yeah? If I wanted to exclude my bad participants, okay. I mean, the ones who were just not paying attention, we don't know what they were doing, right? If I wanted to do that, I could make another data set and remove some of the columns of the participants I don't want to keep in. Okay. And I know we probably do that relatively often. So if you look at your data set in the view window, you can see that each one has a column right next to it over here. So it's not labeled under any of the variables, but it's just the number of the column in the data set. So if I wanted to exclude maybe participant 3, for example, I would type, I usually name my clean data set something else so that I don't lose my old data set. So what I do is just make a clean version. So I call attitude clean, and it will create a data set, but I have to tell it what to put in there, right? So I'm going to tell it I want attitude in there. And this means I want you to take my attitude data set, the one that I just had earlier, and then I'm going to subtract some of the columns or rows in that data. Okay, so I'm going to, let's say I wanted to remove 3, right? So I'm going to do minus C, parentheses 3, and then a comma. And this is going to remove the 3rd row of my data. Actually, the comma goes outside the parenthesis. Sorry. So do 3 and then a comma. Now, if I wanted to remove more than one, so let's say I want to remove, I don't know, 14 and 28, I would just do comma 14, comma 28. And this will remove all 3 of them at once. So if you're going through your data set and you identify maybe 10 rows that need to be removed, I would recommend moving them at the same time, because if you remove one, all of the other ones go up and now their numbers have changed, but they don't update the numbers. So I'll show you. So let's say I just removed 3 right now, right? I run that, I need to tell it I want to see this data set because it's different, right? So I do view attitude clean. And you can see that it goes 1, 2, 4, right? But when I go to remove, let's say 4 is the 3rd one now, right? And if I run that command again, I don't think it will remove 4, will it? We'll find out. It doesn't, okay? Because you have to use the number that's corresponding to that number. So then if I wanted to remove, like, I don't know, 10, I would just do the same thing, but I would do 10. And what you can see here is that it has removed the one with the 10 next to it. Okay. Yes.
Are you
I didn't
able,
view it again. What? Yes.
are you able to remove like big groups at a time? So like,
Yeah.
let's say, but instead of typing it in manually, like 10, comma,
I think
11,
you
comma,
could do.
12, could you do 10 through like?
I've never tried it, but I think you could do, let's see, it's just do attitude clean 2 or whatever, 1, 2 equals attitude. I think, like, in theory, you might be able to do minus C, and then like maybe you want to remove 10 to 20. And then if I, yeah, you would use a colon because it's saying, I think it works.
So
Did it?
like,
Okay.
Like row 10 to 20.
Yeah, so 10 to 20, just like variable to variable.
Okay.
And then if I wanted to view attitude clean 2, you can see, oh, it did not. No, it did some. I don't know. Did I, maybe I didn't type the notation correctly. Let me try adding the comma just because. Yeah, you need a comma, sorry. Yes, it does work.
Another comma.
You have to put a comma after the parenthesis here. And I forgot that the first time,
Okay.
but it does work, yeah. So you can use the colon notation to remove a whole subset. Just for fun, I want to do something else just to see. Sorry, I get real excited about this stuff. Okay, so if I wanted to remove, I don't know, let's be theoretical. If I wanted to remove column 10, and again, every time I'm referencing the base attitude data again so that I don't mess up what I've just played with, because that's already missing stuff. So if I wanted to remove 10 to 15 and 21, I don't know. We're gonna find out. Oh, I need to type view. Oh, that is not, okay. So it did take out 10 to 15 and it took out 21. So if you want to remove a subset, but like another view at the same time, just add each section in. So then in theory, you could also remove 21 to 25 if you did it that way. So really easy ways to clean up your data in here, even though you're using code and it's not like user friendly, you can still do these things pretty quickly. Let's see what else I have. Oh, right. I wanted to do another one just out of the variables we made. to show you that it does work in there, but I'm gonna attach attitude again because I added that centered variable and I changed my y variable as well, right? So if I do model 3 equals LM log rating by centered complaints multiplied by raises, so I get the interaction, then I can run that. And it will, I don't have to tell it the data because I did reattach my data set. If you didn't attach your data set and you didn't look at it, R will remember that you've changed it. Because you haven't, if you want to see it again, you have to ask R to show it to you again. But if you want to create a model with the variables that you put in there, you don't have to change anything. You can reference it as data equal attitudes, and it will know that you added 2 variables in there, even if you didn't view it. Because R knows what it just did to your data matrix. So I can enter, and then just summary model 3 for fun. And you get all of your regular output again. And you wouldn't want to because you transformed your Y variable, but you could get your AICs out of that and compare it to other models that you've made. Again, you can't compare that because your Y variable has been transformed, but if you were to do other models, you could do that. Oh, and last thing I wanted to talk about, if you changed your data set and you want to save it, so once you clean your data set, you want to save that data set in maybe a CSV file, you would just do the write.csv command. I think Kelsey may have talked about this. And you would name it and tell it where to put it. So you want to tell it, I want you to save my attitude data set. Right. And then you would tell it to do the file and whatever you want to name the file, make sure you put it in quotation marks. So I'd call it attitude version 2, or maybe you want to call it attitude clean version, doesn't matter. I've just saved it to your computer, by the way. And this will save in your directory. And you're like, oh, my directory, where is that again? Because that's what I do every time. Is it? I don't remember. I probably wrote it in here. Yeah. Okay. So session, set working directory, and then choose directory. And this will show you where it will go. And you can also just, if you wanted to go to that file on your computer, just remember where it is, go to your desktop and go to R, and then you would find it, this computer. For your computer, you might have your directory set somewhere different. And if you used your directory a lot, you probably already know what that is. Does anyone have any questions about stuff I've gone over? Okay.